Hi, here we have another question from Iranian Mathematical Olympiad, round number 1, year 1997. The question says we have a triangle ABC, AB is equal to 4, AC is equal to 5, and BC is equal to 6. We draw the altitude A prime and extend it until it intersects with the circumcircle of triangle ABC at point A double prime. Same way we do it for the other altitudes. So B prime we extended, it intersects at point B double prime, and CC prime we extended, it intersects with the circumcircle at point C double prime. The question is to calculate this expression. First round of Iranian Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions and 3 hours to answer them. So each question approximately 6 minutes. If you answer correct, you get plus 3 points. If you answer wrong, you get minus 1 point. So you must be very careful when you answer the question. In this question, actually, the geometry was not given, only the text was given. So this is what I added myself. So you have this text, and then these are the options that you have to select. This was among moderate question, not very difficult, but also not very easy. So maybe spend 5 to 10 minutes, try to solve this exercise, and then come back and see the solution. All right, so let us look at the solution. We have this triangle, and we notice that the angle BCC prime, so this angle, plus angle B is 90 degrees. Same way, the angle BAA prime, so this angle plus angle B is equal to 90 degrees. Therefore, these two angles are equal. This is what I have written here. BCC prime is equal to BAA prime. Also, we notice that the angle BAA double prime, so it's the same as BAA prime, this one is in front of this arc. So this angle is equal to the arc BA double prime divided by 2. If we look at this angle that is here, BCA double prime, this is also in front of the same arc. Therefore, these two angles are equal. So this angle is equal to this angle. But this angle itself is equal to this. Therefore, these two angles are equal. Now, if these two angles are equal, this is 90, the other one will also be 90, and this side is shared between these two triangles. Therefore, these two triangles are identical. So we conclude that triangle CA prime A double prime is identical with the triangle CA prime H. Therefore, these two sides are equal. A prime A double prime is equal to A prime H. Same way, we can show that B prime B double prime, this side is equal to B prime H. And also segment C prime C double prime, this is equal to the segment C prime H. All right, now we are going to evaluate the expression that we have to evaluate. Instead of A double prime, instead of this, I'm going to write A prime plus A prime A double prime. So instead of this, I write it like this, and A prime divided by A prime is 1, and this one will be remaining. We do the same thing for the other two fractions, and we add the 3, 1 together, so we get 3. So the expression is equal to 3 plus A prime A double prime divided by A prime, and so on. Instead of A prime A double prime, I'm going to put its equivalent. So same way for the other one. The expression will be equal to 3 plus A prime H divided by A prime plus B prime H divided by BB prime plus C prime H divided by CC prime. Now let's look at this. A prime H is this segment, and A prime A is this segment. So the ratio of A prime H divided by A prime A is actually equal to the area of this triangle divided by the area of the triangle ABC. Instead of these fractions, I can write the area of this triangle divided by the area of triangle ABC plus the area of this triangle divided by the area of triangle ABC, and so for the other one. Because the denominators are the same, is the area of triangle ABC, I can keep it and then add the denominators together. If we add the area of these three triangles, it becomes the area of triangle ABC. Therefore, all of these together will be equal to area of triangle ABC divided by area of triangle ABC, which is 1. So 1 plus 3 is 4. Therefore, the correct answer is option A. Let's see what we have learned. In a triangle ABC, if we extend the altitudes to intersect with the circumcircle of triangle ABC, and assuming H is the orthocenter of ABC, we know that H A prime, this segment is equal A prime A double prime. And same way for the other parts. So H B prime is equal B prime B double prime, HC prime is equal C prime, C double prime. Sometimes it's very helpful if we know these basic properties of a triangle. If the geometry question is more complicated, you want to use this knowledge as a base when you approach a complicated geometry exercise, because then by default, you know that these two segments are equal. You're not going to prove them during the exam. You maybe need to write the proof, but you already know that this is true, and it can help you to go one step further much faster. This kind of basic knowledge comes from solving many exercises, reading geometry books, so that you know the basic properties of triangles, circles, quadrilaterals, and so on. All right, so that's all for this video. I hope that you learned something new. See you next time. Bye.